say rolling. Never say speed.
That's all right. My only acting experience this week has been from being in a skit with Patricia or no, I mean she's called. So. All right. So welcome to Matrices Day 2. Some of you guys were doing homework yesterday, so missed Matrices Day 1. But I just wanted to go over this because matrices are, one, I'm just saying, an interesting topic, but they're also very likely for you guys to come up in a future course. Like, we're the engineers in here. Future engineers, you're going to see a lot of matrices. You might take a course called linear algebra, which is just all about matrices. And scientists, you might see this too, like matrices come up in pretty much every math course after calculus. Because they're really useful. So we're going to close off with this stuff here, the what did you notice from yesterday. So for those who were doing the homework in class yesterday, just to catch you up, a matrix is something that looks like this. It is just a group of numbers. It has a certain number of rows and columns. And so we'd say this matrix is 2 rows, 3 columns. This matrix is 2 by 3. The other matrix is 3 rows, 3 columns, 3 by 3. Now matrix addition and subtraction is pretty simple. You just add and subtract each piece. Matrix multiplication requires a little more work. Those who were working with me yesterday, you can probably do this without my explanation, but I do want to explain it to those who are new to the matrix game. Because I don't think you guys saw this in Algebra 2. No, they saw it last year. You did? Physics, maybe. Okay. So, how matrix multiplication works is, whatever the first matrix is, you're going to take the first row of that first matrix, multiply it by the first column of the second matrix. What that means is I take 8 times 1 plus 5 times 0 plus negative 2 times 0. What am I going to get there? 8. I mean, this is a pretty easy matrix multiplication. 8 times 1 is 8, 5 times 0, negative 2 times 0, 0. Now to get this second number here, I still am in the first row, so I still take the first row, now I multiply it by the second column. 8 times 0, 5 times 1, negative 2 times 0. How do I get there? Five. See how I get 5? Tried to do matrix multiplication too fast. So it comes from taking each of these 3 to multiply by each of these 3. Now the last column, 0, 0, 1. Same thing. 8 times 0, 5 times 0, negative 2 times 1, negative 2. And then the next one, you guys should get that. Huh? Your grade is boosted now. Alright. And there should be something pretty obvious here. What do you guys notice? What just happened? Same as the starting matrix, right? Our answer is the same as the starting matrix. And that only happens in this special case because of this matrix here. This matrix is called the identity matrix. We call it I. Whenever you multiply by this, you're going to get the same matrix as before. When we're doing this with numbers, it's like, what do you need to what number can you multiply by for the number to stay the same? 1, right? 5 times 1 is 5. It's like the same thing, but in matrices, you have the identity matrix. All right, do the second one, and there's another cool pattern showing up here. What?
You do roll like
I'm not supposed to put 3 by 7. So, what he did here
Espérate, pues.
you take this, and then he also put this. It's going to be 1 times 7, 1 times 5, 1 and then you add it together. And it's 7, and you have to be able to subtract this and you divide it. And then this, you multiply it with this, and then this with this, and then you get this number, and since this is the first row, you do it for this one, then it's 3 by 3, so you have to do 1, and you have to multiply this by each one, and then this by each in the middle, by each one, and then this by each one, and then you go to the second, and then it's the same thing. And then it's equal.
¿Y cómo va a ser? ¿Y va a ser lo mismo? The teacher told us.
Show me how you did the wording. Okay, so you go to 1 times 7, and then I go to 1 times 7, and you go to 1 times 7,
Patricia too, she also had one of the highest signature scores ever. So everyone at North Central sees.
Wait. You did 3.
And by the way, you might realize this is a different class than the other one we're filming. There's just a mix-up with the schedules. So you got a new group of students. Guys, everyone, North Central is watching you later in the week. Yeah.
Let's see if this is right.
And you know, whoever else decides they want to watch this. Alright, when we multiply this out, we should end up with this thing.
You see, this is wrong anyway.
No, we didn't end up with that.
No. Oh, because you forgot the 10.
No, there's not a 10. I made that same mistake. I made the same mistake. I just thought it was 10 times. It's like a 10. It's problem number 10. So you should end up with this. What is that matrix? Identity. Right, and what we just found is these two matrices, when they multiply to the identity, these are inverses. These are inverses. Right, when you can multiply two things to get the identity, they're inverses. The way we write that, if this is matrix A inverse, it's just like how we were writing, we know function inverses. It's just like, if you're just multiplying by one number, the inverse of just a single number itself, something you do know, it's 5 times what equals 1? 5 times what equals 1?
1/5.
1/5. Right, that's basically what we're doing. It's just a lot trickier with matrices to find the inverse. We're just multiplying to get the identity. Alright, inverses are useful for what we're about to do. We've done, what matrix operations have we done?
Adding, subtraction, and multiplication.
Adding, subtracting, multiplication. What are we missing?
Division.
Division. Because matrix division is not, it's kind of a lie to even call it division. But it is incredibly important, and it can actually end up being really tricky to do matrix division, and like some mathematicians devote their whole life to try to figure out ways to solve matrix division problems. So how it's going to look is, it looks something like this. I have a matrix times A. A is another matrix, and I want to know what A is so that you get the answer on the right side. Now, this would be easy if I just left it in single numbers. If it were like 5 times x equals 23, what would you do to both sides? Divide by 5. For this one though, you can't divide by a matrix. What you need to do is multiply by the inverse of the matrix. So if I multiply by the inverse of this matrix times the inverse of the matrix, what's going to happen over here?
Cancel. They cancel out.
Right, when you have an inverse times itself, look at the page before, you end up with
1.
the matrix itself. You're going to end up with like the identity, but this whole left side is going to end up giving you A. And then on the right side, you're going to get whatever that actually is. Now, finding matrix inverses by hand is a painful process. We're not going to go through that here. If you take differential equations, you'll probably go through that there. But we can use our calculators. So you guys can take out your calculators. And does anyone not have their calculator? Denitza? Great. You can do the calculator guide up here. All right, so how do we write a matrix? Guys, what's the way to write a matrix? Yep, you need to find the shortcut. You can go to the button next to the Bible. Do that there. All right, we're doing a 3 by 3. Yeah. Okay.
It opens the door at 7:45. Let's see if it's still open.
So guys, just start typing in this matrix. And once you type it in, we want the inverse. The way you do that is as if you're going to write an exponent. So do you know the exponent button? You're going to raise it to the third power. Yep, so you raise it to a power, but the power should be -1. It's kind of hard to see. I'm going to show up.
¿Es la cucaracha?
Ahí está.
Ahí está.
No, ahí está.
Ahí está.
Right, so we have, and if you click enter, it'll find the inverse.
Wow.
Right, oh, and this is the one from the page before. No? Oh, it actually is, they're the same. So if you turn to the page before, I didn't realize that these are the same. This is the same matrix as the problem before. Anyway, we have the inverse there. What do we want to do with the inverse?
Multiply times.
Times.
No, times.
Not. We don't need to multiply it times the left. Times the thing on the right. Ay. This one, ay.
Ey, no se quiere cambiar.
So if you want to meet your partners here, this is Michelle. There's Blanca, there's Yesenia. Denise is over there by the calculator guide. She forgot her calculator today.
Saludos.
Over there we have Patricia, Valeria, Leticia, and Ever. Ever is awake right now, so that is good news. Right here we've got Lizette and Nelson and some people on that side of them doing their homework.
They're bad people.
Now that I've embarrassed them all, let's come back.
You forgot yourself.
Oh yeah, you.
They know me. I've introduced myself in the previous video.
That's Mr.
I'm Mr. Link.
Mr. Link. Oh man. So man.
Extreme. Have you guys seen Wayne's World? Yeah. Really awesome.
Mr. Link.
Extreme close-up. Extreme close-up? Or what is it?
And that's Mr. Link. Mr. Link, say hi.
Is that the movie?
Mr. Link.
Hi, my name is Mr. Link. Now you get an extreme close-up and see that I need to shave. Okay.
And that fade.
Alright, let's get back to the problem here. I got a little distracted. Yesenia will figure that out. So we multiplied these two, and we got -5, 8, 1, 1, 2, -1. What that means? What does that mean? This is what A is. And if you don't believe me, let's prove it. Denitza, can you type in the matrix 1, 3, 3, 1, 4, 3, 1, 3, 4, multiply times A, times our answer? And this should give us the matrix on the right. This should give us 4, 8, 5, 9, 6, 7. I just want to prove this to you.
Lo estás quitando. And that's just it.
There we go. Look. Magic. So this is the power of inverse matrices. Alright, you got one practice problem, then we're going to see this and some application problems, some systems of equations. So we can get started. Oops.
La que está hablando es Yesenia.
44. 4.
I'm doing my work. You do it then.
Alright, 4. Wait, across it. 4, 0, 0.
Why are you distracting me? I'm not distracting you.
0, 0, 2, 0.
Wait, shouldn't it be 18?
0, 1, 2, 0.
27 minus 1/3
1, 0, 0,
equals
1.
t cubed minus 9 equals 18. Why do we you divide it.
You found it? Alright,
What the?
Yeah, but I understand we're not dividing like that's if we're finding average velocity or average something.
That's
Yes,
it.
that's what we're the tricky parts is first, why is the point so slope is 2.
Excuse me, I've been done. What do you?
Alright, error dimension. Yep. What are the dimensions of the first matrix?
4 times 4.
4 by 4. What are the dimensions of the second matrix?
1 by 4.
Oh, that's illegal.
That is illegal, right? So we're trying to do a 4 by 4 times a 1 by 4. That's not going to work. Why?
The 4, the 1 don't match.
the inside numbers need to match. The 4 and the 1 need to match. This is what we were looking at yesterday. But we made a mistake. This problem is a little bit different than the one before. Look at the problem again. What's different here? It's B, not A. Look at the B though, there's something about it that's different. The position, and it matters. It comes before the matrix. Right now we have B times this matrix. This 4 by 4 equals this one here. So now when we want to get rid of this matrix here, I know I didn't write in all the numbers. We're going to use the inverse, but not on the left side, because that's touching the B. We want the inverse on the right side. And I know it's not like the best notation the way I'm doing it right now, there's just not really an easier way. If I'm going to multiply on the right side over here, that means I'm going to multiply on the right side over here. So what does that mean we need to change in this? Did you take the inverse of this?
Yes, the one next to me.
But it's this times the inverse. You have to switch the order of these two. And do you know how to do that instead of rewriting everything? Click on the up arrow. Twice. Enter. It's going to copy everything. And now what you can do is you can probably just erase the second matrix and rewrite at the beginning. That way you don't have to rewrite the entire big inverse. And you could also do the inverse in one step. You could just do the right side times that inverse.
Yeah, someone said someone in college, pure practice and they didn't want, so they said, okay, I have my cousin, he don't want it, so they said, he go back home.
All of them?
Yeah, like everything in the box, like everything handy, gum.
That's what happens in a college fair package?
It's because they calculate, they move out, or they get to fly back home.
Well, good for you.
You can't see it because Patty's.
Good. Yep, got it. What are you guys getting?
Negative 27 over 12.
Yeah, that'll probably be the answer, right? So this is our answer here.
Muévete para que vean.
That's how I kick you out of your job. We'll need you in a bit, so you can stay up here. All right. Oh, and it's not projecting. Turn to the next page. And now this is about to make your life easier. You've spent all this time solving equations like this. We actually haven't done this in this class. You guys probably remember linear systems of equations. You might use substitution. Other ways you might solve this nasty looking thing. Elimination. And what was elimination?
You get the same variables for one of them.
Well, isn't that part of substitution? Or there's the other one is I forget what you call it, subtraction, where you could like take this line, this equation, and subtract the other equation. Or a new strategy that's going to save you time. Could you rewrite this as a matrix problem?
Yes.
How could this be a matrix problem? So the 0, 4, 2, right, it looks like it's on the right side. We have something equals 0, 4, 2. but then on the left side it's a little tricky.
1, negative 1,
1, 1, 1, 1, negative 2, 2. How are you getting those numbers? Coefficients. What about the x, y, z? What happens to those?
Those are just variables.
They're just variables, but, so what's happening? This isn't where x, y, z are. Well, we're trying to find x, y, z. Like if you multiply this out, you'd get 1 times x plus 1 times y plus z equals the top one, 0. 1 times x minus 2y plus 2z equals 4, right? You'd multiplying this out, you would get each of those equations. And the reason this is useful is how can we solve this then? Inverse. Right? Take the inverse of this, multiply it by the right side. Alright, take a second to do that. Oh, you're on the next one? You can. Yeah, actually, you can think of that. If you do that, just make sure you take it out of each number in the line.
So like, it doesn't matter, so let's say this was here instead of the x, we have to like move it around, or would it not, like you just write the numbers down?
So, it does matter. The reason this works, what would happen if you tried to multiply like the top row here with the first column there? Or in the second row? Right? So these numbers have to match up with the variables to make whatever equations you have here. So if it said negative 2y plus x, it would still be this one. And you'll see that actually in this problem, because we're going to end up with some equations that don't have a y in them. Alright, 4, negative 2, 2. Or negative 2, negative 2. The 4 is your x, the negative 2 is your y, the other negative 2 is your z. What's cool, like, if you don't believe me, look back at your equations. That first one, x plus y plus z equals 0. Does that work? X plus y plus z equals 0. Works. The second one, what's the second one? X minus 2y plus 2z equals 4. X, 4 minus 2y plus 4, so 8 plus 2z minus 4 equals 4. That works. So it's just cool that this works out, and this is a lifesaver. Because this is like basic systems of linear equations. There comes a point where you start getting systems of linear equations that are just impossible to solve by hand. You can get literally thousands of equations, or even millions, and like there are some problems that go to billions of equations, and you're not going to do that by hand. You need to know how to get a computer or calculator to solve it. That's why these are really useful. Alright, take a second to do the next problem there.
¿Cómo sabes cómo es primero?
I think it's just when this one starts.
Entonces te va a estar.
But it's someone like this one.
Yeah, the inverse working on it.
Oh yeah.
The inverse of the inverse
Personal.
and then the
Times.
I want to hear you.
Remember they're taking derivative thing on both sides. How does the crossover work? Yeah, that's back at you. Well, but it's plus f prime times g. So otherwise it's so f prime derivative of that is you're close. You said negative plus x.
You just done it.
Oh yeah, it's just
Oh, I put your everything.
and then
Where did you take it?
what is d? Well,
Who you think?
doesn't go up. Yeah. Good.
It was really difficult. You can still buy a ticket. What are you taking? But then it would be too late. You need to find it there.
Yes, nice. Oh, but it's not. And then
Yeah,
you
but that's
and you can
you're gonna have to
you drove, you got it.
connect.
All right, are we getting 3, -2, 0, 1? Yeah? That means x is 3, y is -2, z is 0, and w is 1. All right, now let's take this a step further in our application. Now, step deeper. Now you're not even given a system of equations. You're going to have to come up with these system of equations based on the problem. The sum of 3 numbers is 26. The third number is twice the second and is also 1 less than 3 times the first. How are we going to solve this problem? What might be a good idea to start? Writing the equation. Wait, we need to figure out what equations for these. Right, so we have 3 numbers. Let's call those x, y, z. Right, and that's what you did without even saying it. Let's call those x, y, z. Denitza gave us the first equation. The sum of them is 26. All right, I want to give you guys 2 minutes. Find the next equations. There are 2 more equations that you can create.
But you can find 2 more. I think wouldn't one be the thing, the third number is twice the second.
Oh.
That's 1. And then the other one is 1 times the first. That's the third one.
But Nelson, keep it as variables. The third number is twice the second. Yeah, that's easy.
Oh, right here.
Yeah, Lizette has it.
Peter?
Would it be 2y
Alright, what are you gonna say?
equals
Third number is twice the second.
so the third, not the second. So it'll be 2z equals 2y? No.
What?
So something, maybe we should look at this first one.
2z equals y.
Third number is twice the second.
So let's say
Third number
the second number is 3.
is
The third number will be 6.
z is twice the second.
Like these variables.
2y. So z equals 2y. Oh, and then and the third number is also 1 less than 3 times the first. So the third number is 1 less than 3 times the first. How do you represent that? 3 times the first, 3x, minus 1 for the 1 less. Now these are the 3 equations. There's a problem here though if we try to immediately represent these. I'm going to be ready here. There's a problem if we try to represent these as matrices right now. There's a matrix problem.
There's no number.
So Nelson, you're saying it's not just numbers on the right. That's the issue. Denise also saying the dimensions. But the main issue is I have variables on the right side. If you look at the page before, that doesn't work. You want your variables all in one place.
Can you divide it by y?
So dividing by y, you would end up with z over y, which again is something you don't want because we don't really know how to put that into a matrix. We want like a z plus something y. So there's another thing we can do here. I think I heard someone say it. What do you think? To get just a number on this side, instead of dividing by y, subtract. Right? I could say z minus 2y equals 0. And then for this bottom equation, you don't want the 1. Right? Z minus 3x equals negative 1. Now we have numbers all on the right side. So now what? You can make the matrix, you have to be careful on the left side here. Right? The numbers have to match the variables. So what I'm going to do is, I'm not going to change this, I'm going to rewrite the order. So it's easier so you won't make as many mistakes. Negative 2y plus z. X, you normally wouldn't write that, but 0 times x. And then, so z minus 3x, we'll do minus 3x plus 0 times y plus z. That's it. So now you can write this as a matrix equation and solve it. Take a second to do that. Do these mesh? Do these make sense?
5, 7, 14.
Does that make sense?
No.
Why not?
Because it doesn't make sense. Oh wait, it doesn't fit in the car.
Negative 3, 0, 1.
Wait, but that is the correct answer, right?
Yeah. Well, does it work? Check the something else is wrong.
It's supposed to be always
One. In the first one, 1, 1, 1, 1, 1.
5, 7,
Or just check in terms of the word problem. Do those add up to 26? Is the third one twice the second? Alright, are we getting... We should be getting 5, 7, 14? Are we getting that? Nelson is there, Noe, Michael is there, people here?
Yeah.
Does that make sense? Look back at the word problem. Do those add up to 26? 5 and 7, 12 plus 14, 26. Is the third number twice the second?
Yes.
Is the third number 3 times the first minus 1?
Yes.
Yeah, so it's going to be okay. Alright, what we're going to do, we have 7 minutes. I want you and your partners to choose any one of the practice problems below. Anyone, choose your favorite word problem. You're going to have to represent this as a matrix problem and solve it. Alright, and Denise, you can head back to your group.
You're not going to see what variables matter.
Monkey?
Yeah, like you have to see what variables matter. I think it's that I'm just saying.
My students.
Ever stop eating?
Why
does ever have a baby?
which problem you guys taking?
Number 6, kids.
My uncle body. Body? I said body.
Which one do you guys taking?
Ey, esto no me cierra. Sí.
Which problem are you guys taking?
Este va a ser mucho.
Which one are you guys doing? 5, okay. Crustaceans. No. I agree with the first equation.
Since only the spiders and the crabs have legs, wouldn't that be just magic?
If you have 3 spiders and 3 crabs, how many legs are there? If there are 3 spiders and 3 crabs, how many legs are there?
And that's Blanca. She don't know nothing. That is true.
3 spiders and 3 crabs.
3 spiders. Spiders have 8 legs.
That's Yesenia.
And then 3 times.
Blanca, mira para acá.
10. Oh my gosh. Crabs have
54.
54, right? Not 6. Not 3 plus 3. That's what you're doing here.
And that's Anita.
That's Michelle.
So,
She being shy today.
so then I have to figure out how many legs each one has.
Yeah, it tells you.
I mean, like,
That's Blanca. She's
I know there's
Blanca.
18. I mean, 96 like 7, 1 times 10. I mean,
No, but look at the setup you said you did.
Is it right?
Yeah.
That's Yesenia.
80 times 10. Oh my god. Famous for what?
And then now Patty has a question.
Yes.
Patty is Patty is the brains of the class.
Oh, we did it.
But then even white line. None of matching the right.
Then Blanca did it. Ella no va.
Do your work. You've been writing your name with my pen. Waste time.
Hold up.
I didn't know crab fish in there.
Wait, this is a 2x2,
Jose.
All right. Stay focused on your work.
Can we see the video?
It'll be online. You might have to hold this.
I'm gonna be YouTube famous.
Alright, so I know a lot of you guys didn't get to finish. So those are doing the snakes, crabs, and
Adios.
what's the other thing? Spiders. Well, guys, I can give you the answers.
Snakes.
You have 2 possible answers. 8 snakes, 2 spiders, 8 crabs, or 7 snakes, 7 spiders, 4 crabs. Anyway, I will. I'll see you guys tomorrow. Wait.